Thank you very much. Appreciate the opportunity. So I've walked around and talked to several of the teams with their poster sessions, and I found something very ironic. About half of the poster sessions cut through applications that I concentrated on in my career. And these ranged from seeing a vibration, well, not a vibration, I guess a vibration reduction device for an unmanned air vehicle all the way to a material tailored for insoles of shoes. So within my career at Georgia Tech, I actually started in our UAV lab many years ago, or 27 years ago, and in my graduate education, my advisor pushed me in the direction of looking at what we had at the time called computer integrated manufacturing systems. Well, within the SIMS program, it was mostly concentrating on CNC machining and how that would work into the workflow on a factory floor. But then we had some new devices showing up in our mechanical engineering school, an SLA 250 and an FDM 1000. And I became very interested in this. So I said, for my project, I want to look at some applications with these new devices. And that's how I got started in additive manufacturing, and that's probably 25 years ago. In that time, I started out with the aerospace applications. We actually made some concept prototype models of micro unmanned air vehicles back in the early 90s using the FDM 1000 and the SLA 250. And then moved on from there to building wind tunnel models. And later, we had some local dentists come to Georgia Tech and ask us about this new process called Invisalign, and I hear they use a process called rapid prototyping, which was the term at that time, and said, do you all know anything about it? And our Economic Development Institute came and grabbed me because I had a reputation around the Research Institute for using this new technology in prototyping, and I became very interested in the healthcare side of things at this point when I started investigating that under a small consulting grant with our Economic Development Institute. Next thing I know, I become linked up with our School of Applied Physiology, and they're very interested in the idea of utilizing rapid prototyping. Now it's becoming, the term additive manufacturing has pretty much supplanted rapid prototyping. We're in the late 90s, early 2000s, and we're looking at utilizing it for production of prosthetic limbs. Later, I received a research grant from the Navy where we're looking at fitting prosthetic limbs and distributing the pressure within the socket around the residual limb of the patient, of which I believe the graphite-infused PLA, or the graphite-infused material, looks like a fantastic material for building one of these liners, because the one thing we were looking for at the time was a combination of very low elastic modulus and high heat conductivity, and in my mind those two don't usually go together very well. Then I was hired by Jerry Grant at the Navy, hired out of Georgia Tech. Now, you may know Professor Grant. He's over in the School of Dentistry now. He spoke, first speaker yesterday. I worked at Walter Reed for Captain Grant at that time. He was a full captain in the Navy. I worked for Captain Grant for 6 years at the Navy as his chief research engineer. And we addressed a wide variety of problems in healthcare, from direct implants to diagnostic models to oral appliances, dentistry, dental problems. So it's kind of very interesting. I saw an entire span of my career reflected in several of the applications the students presented, even down to the collimators for X-ray and for radiation treatment, because unfortunately I'm a cancer survivor and had to go through radiation treatment, so that one hits close to home with me as well. In all of these, I see additive manufacturing coming in to solve basic fundamental problems in the manufacturing of a better product to address the need. So I was really thankful to be invited up here and see what you are doing here at University of Louisville. I would like to talk to everybody else a little more, and I'm very excited to see the labs, especially later today. Thank you very much.